Hi, welcome to the video on drawing Lewis dot structures. In this first video, we're going to take a look at what we call regular structures, where they are all single bonds and there's a central atom. It may be helpful to follow this video along with the packet that is linked. You can do your work on the left column of the packet, and on the right column you can fill in the steps. All right, here's our first example. We're asked to draw the Lewis dot structure of CH2, Cl2. And the very first step is to draw the Lewis dot structure of all the atoms in the molecule. So when we take a look at this molecule, we can see from its chemical formula that it has one carbon, two hydrogen atoms, and two chlorine atoms. So I'm going to start by drawing the Lewis dot structure of carbon, since that's the one that's written first. Carbon is in group 14. It has 4 valence electrons. And remember, when drawing the Lewis dot structure of the atoms, you make sure you give each corner 1 electron before you pair it up. So in this case, all 4 corners get 1. For the hydrogen, it's in group 1. It has only 1 valence electron. And again, I drew 2 of them because there are 2 hydrogens here. And so the next thing I need to draw are the Lewis dot structure for the 2 chlorine. Chlorine is in group 17. It has 7 valence electrons. This is what their Lewis dot structures look like. The next step is to pick the central atom, and that's the one with the most unpaired electrons. And unpaired electrons look like a single dot. So what I'm going to do is I'm going to take a look at all my Lewis dot structures and figure out which atom has the most unpaired electrons. So taking a look at carbon, first I see it has 4 unpaired electrons. Each hydrogen atom has only, some mistake there, that should say 1 unpaired electron. And each chlorine has only 1 unpaired electron. So with that being said, that means that carbon has the most unpaired electrons. It has 4 unpaired electrons for a single dot. So that's the one that's going to go in the center. Third step is to connect all atoms to the central atom with a single bond. So if we take a look at this, our Lewis dot structure of the atoms here, we want to connect all of them to carbon since that's our central atom. And what I'm going to do is I'm going to connect the unpaired electrons of each atom to an unpaired electron in carbon. So I can connect the unpaired electron of the chlorine to that top one there. The hydrogen, I connected it to an unpaired electron on carbon. The second hydrogen, I connect to the bottom unpaired electron on carbon. And then the last chlorine, I connected it to the left unpaired electron. It's important to note the order doesn't matter. The main thing is the numbers of bonds are correct and you have the right type of connections. All right, so once we've done that, we're going to move on to step 4, which is to check for unpaired electrons to see if there are any more. And if you look at our structures, all of the unpaired electrons we had are already paired up. These 2 dots together are not unpaired, they are paired together. We call those lone pair electrons, pair meaning 2, so they're 2 together. So our structure has no more unpaired electrons, so we can move on to the next step. The 5th step is to clean up the structure, and I'll put a little asterisk there, don't forget the lone pairs. So what do I mean by clean up the structure? Notice how all of the bonds here are kind of drawn they're kind of loopy, they're not like straight lines. And if you looked at Lewis dot structures before, you notice that the bonds are usually drawn as straight lines, either going up and down or to the left and right. So we can clean this up by first starting by drawing our central atom over again, and that's what I've drawn here. Drew the central atom, and then what I do is I just look around my central atom and figure out what type of bonds are connected to the central atom. So I notice at the top there's a carbon-chlorine single bond, so that's what I just did. So instead of making this line look like a loopy line, I just draw it straight up. And then if I go around to the right, I see there's a carbon-hydrogen single bond, so I'm going to draw a single bond going straight out. If I go around to the next part here below it, I see another carbon-hydrogen single bond, so I draw a carbon-hydrogen single bond going straight down. And over here I see that there's a bond to a chlorine, so I'll draw a bond going straight out to the left. Then I need to go back and just take a look at my structure and make sure I didn't forget any lone pairs. If you notice on the chlorine atoms, there are all these lone pairs, so I need to make sure I put them back on the chlorine atoms. And each chlorine atom has 1, 2, 3 lone pair electrons, or 3 lone pairs. So I go ahead and I stick them on, and so this is my cleaned up structure. Okay, the next thing we're going to do and the last thing is just basically check our structure for, really what we're going to check for is the octet rule. Remember the octet rule says all atoms have 8 electrons around them except for hydrogen, which has 2, and boron, which can have 6. So let's start off with carbon and let's see how many electrons are around it. Now when we say electrons around, we're looking specifically for electrons in bonds and also lone pairs. This carbon has 4 bonds touching it. So that's what I'm going to count. I'm not going to count the lone pairs up here, for example, because these lone pairs are not touching the carbon, they're touching the chlorine atom. So anything that's touching the carbon is what I'm going to count. Okay, so let's go around and see if carbon has 8. So in each bond, there are 2 electrons. There's 2, 4, 6, 8 electrons. 4 bonds and 2 electrons each. It has, so that carbon has 8 electrons, and so carbon makes the octet rule. Let's move on to trying out the chlorine now. So there are 2 chlorine atoms. I'm only going to do one of them because these chlorine atoms look exactly alike. And what I mean by exactly alike, each chlorine atom has 1 bond attached to it and 3 lone pairs. So once you check one chlorine, you've checked the other since they are exactly the same. Okay, so looking at the chlorine, first thing I notice is that it has 1 bond attached to it, so there's 2 electrons there. And then 4, 6, 8 from the lone pairs. So to mathematically look like one bond with 2 electrons each, plus 6 electrons from the lone pairs, and again, in both cases gives you 8. So notice you can either set up an algebraic expression to count how many electrons are around the atom, or you can just go around counting it the way that we did in this example. The last one we're going to check is the hydrogen. And again, I only have to check one hydrogen because both hydrogens look alike. They just have 1 bond attached to it. And we know that in 1 bond there are 2 electrons. And so hydrogen has 2 electrons. Now remember, hydrogen is an exception. It should have 2 electrons, so it also follows the octet rule. Okay, so that's it for doing the regular examples. At this moment, if you haven't done so already, I would either redo or do for the first time, practice set 1, which is linked in the playlist there. I hope you found this video helpful. Have a quality day.